Hi everyone. In this video, I want to walk you through a data engineering project I just finished building. Before I go deeper into the project, I just want to thank Ifeanyi and the tech community for giving us this opportunity. It was a tutorial that was actually free, and they taught us. Ifeanyi himself taught us all the tools needed for the project to work. I'm glad I was in the midst of him and other colleagues as well. So the project is as simple as that. Take your take a particular data from your file storage down to the which was the source down to the destination which was which is BigQuery. As you can see from the image, you see an arrow coming from the file storage, working down to the class storage and going to BigQuery. The arrow will look like something very easy, but like it's actually like a lot of work was done in this project using tools like Google Cloud, which was GCP, Google Cloud Platform, which orchestrated our cloud storage and BigQuery. I also use Terrafrom. Terrafrom is the infrastructure as code and based platform. It can be used to create buckets, BigQuery tables, any cloud platform you want, be it GCP, AWS, Azure, and so on. Then our Airflow, which was like I think the main orchestration, the main engine that does the extraction, takes the data, move it to cloud storage, then finally the destination, the BigQuery. Yeah. So um, it's about understanding how Airflow works as an orchestration tool in data engineering, specifically for moving data into Google Cloud. So the project was just revolving around Airflow, get taking data from a particular source, going down to destination, and the key tools that were used around it. So now I'll move to my VS Code to show you how the project was set up and how everything worked hand in hand. So let me move to my VS Code right now. Yes. So first thing first, I know you see a lot of folders and files there. Well, let me just explain what each means. So first thing first, before I did anything, I first noted the source of my data. Where is my data coming from? So my obviously I have told you in the previous few seconds that my video was stored in my file storage, which is this. So you can see it's from the document Niger place, these folders, then over here user clean. So user clean are just constitute the user ID pharmacy now. Or let me even show you what the data consists. So yeah, the data consists user ID, pharmacy name, owner name, phone number, email states, city, registration dates, account status, pharmacy license number. So this is like more or less like a B2B marketplace data set. So essentially what I want to do with this data is to analyze the data in BigQuery. Yeah, analyze the data and know, for example, which to know which pharmacy are in Lagos, which pharmacy are, yeah. So like just question the data, play around it. That's the essence of it. So although you might be saying that like asking questions like why am I putting out people's data publicly? First and foremost, this is a fake data. I created it with Python. So Python made me create this data. It was easy. It was easy to create the data with Python actually. So all these phone numbers, name, everything is just fake. Get this fake. So let me move down back to my VS Code and explain the processes that it took for me to make up this project. So first and foremost, I will talk about Terraform. Now, before any automation happens, I need somewhere for the data to land. Obviously, just like I explained, that's where Terraform comes in. So it's my infrastructure as code tool. I use it to provision everything on Google Cloud. Let me explain what those provision everything on Google Cloud means. So Terraform consists of my Terraform folder consists of three main files: the main.tf, the local.tf, and the variable.tf. So in the main.tf, Terraform is written in YAML, like YAML. So in the main.tf, I provision my Terraform and got the required provider. So this with this version, this I don't think it's the latest version though, but I just use it. I got the source which was hash copy Google. So hash copy is the one that the Terraform is under hash copy. So I got the required provider, yeah, to make up my Terraform block. This is before you do anything, you have to state this Terraform block. Yeah, and the latest version. It's more like saying that, like, okay, I want an app. I'm just giving an example essentially. So I want an app. I need the app version, the latest version, and everything about that app, which is Terraform. I stated it here. Then the next is my provider block. Since I've gotten Terraform now, which of the platform am I using? Get which of the cloud platform am I using? I'm using Google Cloud Platform GCP. So I need to state the project ID. I needed to state the project ID and the region itself. So after this, the next step now is for now. I have the Google, I have the platform, the Google platform. What am I doing on GCP? What are the things I'm doing on GCP? Now, this is where the resource block comes in. So in Terraform, you will have you in GCP rather, you have different resources. What are you doing? You can decide to create buckets, you can decide to create tables, you can decide to create data set. I did everything here. I created a bucket. You can see resource block for a bucket. This is the name of the bucket, the location of the bucket. Location means that, like, where am I creating the bucket? Then first show is true, storage classes, this and that, then versioning. So all this I cannot essentially explain everything correctly right now because it will take a lot of time. But you can go to the hash copy and Terraform documentation to read a lot about this thing. So if any project you work in, you can decide to use whatever rules you want to use. I use life cycle rule, I use action, I use a lot of rules just to create the buckets. Yeah. Then down to the resource for BigQuery now. I created a BigQuery dataset. So this dataset definitely has an ID, also has an education as well. So everything here, all the codes written here are written by me, obviously, and also I got the code from the from the hash copy website. You get so connected together because you don't need to cram. Yeah, you don't need to cram the code. Even if you forget, you can just easily go back to the hash copy website and get the code back. But the main thing is for you to fully understand what the code means and what they are doing. That's what I'm trying to explain now. So for resource, I created for the BigQuery resource, I created a data set. So the data set is more essentially like a folder where your table is going to be. Yeah, so this more like a folder where your table is going to be. After then, I now move to create the table itself, the BigQuery table. It involves the dataset ID, the table ID, yeah, then also the schema. I'll explain the schema for you because obviously you'll be waiting for where's the schema which consists of the columns, the data type, and so on. So, but I didn't put the schema here for one reason, and I'll explain it later for you. So after this, I now went to um, I know that from my explanation now you might be seeing some stuff like, oh, the project ID, where's the project ID? Why am I seeing VAD of project? This is what variable.tf does. So a variable in Terraform is more like a usable file. You get. So let me explain further. So for example, if I am running on a particular project, like today I'm running on a particular project, and the next day I want to like run another project, what I will do is that, like, for example, if I had put an ID here, probably 1 2 3 4 5 6 something like this, I put this the ID of the project, and next day I have a new project, and obviously it will give me a different ID. If I want the new ID now, come here and like, oh, cancel it. I'll make the work rough, like more or less remove this one and add the new ID. So the variable.tf, what it does, it's like a usable file that helps us keep. Let me show you how it looks like. So it helps us keep those essential details that we are always like a repetition, the stuff that are always repeating. Essential, essentially helps us keep it. So instead of me like going into my main.tf file, making it up, changing things, changing this, those kind of things, like you might even forget and for example, you wanted to change the project ID and the region, something like that. You probably forgot putting the new region and just left the old project ID and the old region there and added the new project ID. Will cause a lot of things on your project. So instead of that, I created the main.tf file. So I created rather the variable.tf file. So any changes you want to make on your project, you can essentially come to this variable.tf file and make those changes. This is why the variable.tf file is actually one of the most incredible files on the Terrafrom platform. So as you can see, I can't really explain what each of these things means. But if you look through, you see the variable, the project, the region, the location, the bucket. So each of these reusable file that I repeat over and over again, I can easily come here to change it. Okay. Then the next, which is the local.tf file. Yeah, okay, so the local.tf file is one of the newest file I've used on the Terraform platform. So mainly the local.tf file, instead of like writing those BigQuery table schema directly inside the main.tf file and making that file like look messy. So essentially, I just told you that like the variable.tf file. So one of the main reasons why I'm making a variable is to make sure that like the main.tf file does not get over scattered, like we don't put. So it has to be clean neatly for others to understand. So that's also almost the same thing the local.tf file does too. So instead of putting the schema here, but I also mentioned previously that I will show you the chemistry between the schema connecting the local.tf. So from here you will see that like I use schema equals to JSON code. This is essentially how Terraform wants you to state it JSON code. Then you now put the the actual this thing that is connecting to the local.tf file. And see local.table.schema. From here you will see the connection, yeah, table schema with the local.tf. So essentially these are, instead of putting this in my main.tf, I kept it in a local.tf file. um, the local.tf file consists of the table schema, which consists of the columns, the data type, and the mode. The columns, you can see the name of the columns, user ID, pharmacy name, owner's name, and so on. The type, the data type, everything here is string except the date, which was used as date. Then the mode is non-label. Non-label means that like any column can have no values, for example. So yeah, so with all of this, I think I can also do this in my Airflow instead of so. But like I just wanted to do it on Terraform basis to make my table look neat. So once I was done with this, I perform my Terraform code. Now the first Terraform and flow written flow you have to the first Terraform code that you need to write is Terraform init. So Terraform init is actually like initialize your project, brings new important files. For example, this tf state file, it actually contains crucial. I'm not even supposed to show you that, but you know that it contains crucial crucial the crucial like security about the Terraform file. So we don't want to like allow that file go outside our Terraform. Then this backup file is where just in case you need it's like a version just in case anything happens. This is where the backup file is, and it's also rated that you should not change or touch anything on this backup file. It's very advisable that you should not do anything here on this backup file. So, so essentially, these are the what the Terraform, my IAC Terraform looks like. If you go to the project overview, which is this. So this is what the Terraform is doing. Is like an infrastructure based code connecting everything inside this cloud platform. So the first this in which was Terraform in it brings out the files. Then the second one is Terraform FMT. Terraform FMT is very important also as well. Some people do skip it though, but the Terraform FMT helps you to like connect your code together, makes it look more cleaner. You can be writing this code now, for example, putting life cycle um where's this cursor here? Okay, putting life cycle in this place. Once you do Terraform FMT, Terraform will bring it just back to this place, making your code looking more cleaner and presentable. Then the last one I tried did was not last sharp. Before I did Terraform FMT, I also did Terraform Plan. So Terraform Plan, we just what it does is that like it will show you how your code or how your code is going to look when you click Terraform apply. So these are the changes it's going to make. These are your final Terraform orchestration code will look like, and this is what they are creating essentially to show you that they are creating these three major resources: buckets, BigQuery dataset, and the table as well. Then finally, you do your Terraform apply. Once you click that Terraform apply, you see a very sweet, see a very sweet table. You see a very sweet bucket. Also see a very sweet dataset. Let me even show you how it looks like um, on the cloud platform. So this is our cloud platform, and this is actually the table. Let me go to the bucket. So this is how our bucket look like. It's loading. So essentially, this is what Terraform does: create the buckets for us. Yeah. So this are buckets, Niger cat bucket. See, it's the region is and this is the region type. I didn't have time to explain this multi region and region type for you. Then the location is African South one. So I use African Sat one because there are a lot of locations there. For example, if you see different people's buckets, you see Europe West. So why I chose African Sat one is because I want a location that is closer to Africa. I want a location that is closer to Africa. That's why I chose African Sat one. So this is the creation of the bucket. Then let me show you the data set and the table and Terraform created using Terraform Cloud System. Just a moment here, studio. Let me show you. Loading, loading. After this, I'm going to talk about the Airflow. How I implemented Airflow as well. You can see from the folder from the VS Code, you could have seen Airflow as well. So I'm just talking about more part of the project, which is Terraform. So this is the data set created by me, Niger Cat dataset. So if you go down the arrow, you will see the table that was also created, Niger Marketplace table. Now, if you click the table, you will see the schema, the columns, and their data type. Yeah, so see the user ID. So see, initially I initially for my Terraform, the data type were string. So this is why BigQuery is very massive. BigQuery will go inside your data and more or less like, although I will explain this in the later stages, because when our data is moved from my file storage to the bucket down to the BigQuery. BigQuery is like it's essentially automatically goes down to the column and signify that, oh, this column is integer, is not string. Oh, this column is string, is not integer. That kind of thing. That's also one of the most usefulness of using cloud platform system like BigQuery. So let me go back to my project and explain what Airflow does in my projects. Okay, yeah. So so this is for Terraform. Then Airflow. Now setting up our Airflow. Now for the orchestration side, I use Airflow through Astronomer, which manages a lot of this setup and a lot of like the complexity of this setup. I've once used Kestra before, but majorly I think Airflow is better in terms of optimization. Running Astro Dev dot init, like I said, it's just like running Terraform dot init. Running Astro Dev dot init. Initialize your project. Add crucial documents and folders rather, not document. For example, when I ran asho dot asho dev init, I had dot asho folder, I had the DAGs folder. I'll explain what DAGs means. I had the include folder, I had the plugins, I had the test, I had all this folder created by just running asho.init. So when you run that project, the project ran into a Docker container because Airflow and Docker container works hand in hand. The project ran through a Docker container, created an Airflow image and did a running container. So now my project is in a container itself. So I know you must have seen that like, oh, is in my folder, but like currently like this is running on the container. I can stop the container, I can start the container. So Airflow runs on Docker container. Yeah. So this is the folder that was created when I ran the Terrafrom, when I ran the Asho dev, it's just like Terrafrom, it creates the folder and files that Airflow needs. So one important thing you need to understand that Airflow runs inside the Docker container, which I've said, very very important. It's mastered. So now the next step is this requirement of TST, which is also very very important. So now I want to the version is a 22.22. So now it's more like a, okay, let me explain it this way for you to understand. So this is more like a package itself. So you know you have packages. Let me put it as an app in Play Store. So what I'll be doing mostly revolves around this Apache Airflow provider Google. So I needed the package to install the package, so it will have the requirement. There are a lot of requirements under this. You might not see it here. So I needed to have this package. So before I can get this package, I needed to manually write it on this requirement.txt. So the requirement.txt is just like your app, so you can go in there and download whatever packages you want. So I did this majorly. So this is where my is majorly. So the reason why it's added is majorly because this is where my Python packages and my DAG lives. So for this project, I added the provider. The single package gives me access to all specialized GCP operators I need as well. Things like the operator to create BigQuery tables, things like the operator to create to load the table and to move files into cloud storage and so on. So once you do Astro dev init, after you have you can do after Astro dev start after you have written this package. So first thing first, I did Astro dev init. Initialization brought out the folders, the required folders. The next step is that I imputed this package on my requirement.txt, more like you downloading an app. So this app helps me to like run Python operators and the load operator, the BigQuery load operator, the BigQuery extract operators, and so on. So once I've done this, I now run the actual dev start. So after running the actual dev start, what happens is that like it brings up the running container and brings up the website localhost 8080. So if you run this, it will take you out of here to the Astro UI user interface, where you will see how the, let me even show you, where you will see how the Airflow UI looks like. Let me show you one moment. Um, so essentially, this is how the Airflow user interface looks like when you run Astro Dev start. So Airflow with the user interface will pop in like this through a running container. Then you will have your fine, clean user interface. You can see the home button, the tags, the asset, and everything. So before I go deeper into this, I will need to go explain the more what those folders is on Airflow. So let me go back to my let's code. So yeah, I'll explain what each folder essentially does. For example, the where you run, let me start with the DAG. Now, the DAG is like hosts our specific tags and everything. that relates to this project. So each task we are saying that, oh, Airflow, go to this place, extract this data, move it to this place, all that kind of stuff. This is where we are going to write all the tasks. Yes, this is where we are going to write all these tasks. So the DAG consists of two major files, the concave and the concave.py and the GCS BigQuery.py. I will start with the concave of py. So this file just holds bunch of usable values. For example, my data source part, you can see it. So this data source part is like where my data is in Airflow. You get, so I might likely show that if there is time. But you know that like when you pop up an Airflow running container, mm, so Airflow builds this container for you. The file part of where the Airflow is in your container is different from the file part of where it is in your primary folder in your local system. So this is where the Airflow lives. This is where the source folder lives in your Airflow running container. Don't get this mistake because it confuses a lot. So this is the file part, contains the bucket name. Remember the bucket we created. This is the bucket name here. Contains the user file name. So the file we are transporting to the bucket. This is the name of the file here. Then the project ID, our project ID from BigQuery, everything. So I essentially this concave.py is a reusable file. So just like how I explained in Terrafrom when I did that variable.tf, it's also the same thing. So I don't want to keep on be writing this local dot. If I come to the main, because this GCS, I'll talk about it now, is my main file where I write all the tasks. I don't want to be writing it one by one. Like for example, see source, I put data source dot parts underscore parts, that kind of thing. I don't want to be instead be writing the source here. I will go back again and write the source in another place. So I did it in this concave.py to make my project look more neater. So also we state the table schema as well. So I remember telling you that like this, we could have also done the schema here on Airflow as well. Yeah, so we do we wrote the schema, which is very much the same with the first one we did in Terrafrom. So let me explain the GCS BigQuery PY. You can name it anything you want. Any of this concave can actually name it anything you want. Well, I just give it this name. So what this GCF this file is where my dark tags are all come into play. So I imported everything I needed. For example, the date time I need it. For example, you see where I use the date time. I imported the DAG. The DAG contains the required tags um, um, from. So I also imported two specific operators. The local, if you can see from Airflow dots, this operator allows me to move the file from my local storage to the GCS bucket. So these are like more like the engine, the ones that are working. I also imported the local file. This one also takes the. Oh, did I do anything? Did I do anything? So okay, I also imported. Okay, sorry. Also imported the this GCS BigQuery operator. So move the file from GCS to BigQuery. So all these files are essential for my project to be running. So from here, before I can even use the usable file, I have to import it. So I imported it from the file itself for concave. So from concave, import what is inside there, which are the data source part, the bucket name, the GCS file, and the project ID. Imported everything that is needed. Now, this is the second piece of what is written under this under my DAG file, the main file. This is the second piece. Now, the default DAG, this is just like a dictionary of this is just like a dictionary that settings that apply to every task in my DAG. Things like who owns the DAG, for example, owner, like my name. Things like the depends, what it depends on the past. Things like the start date. Things like the email on failure. This is like the email which this email dot failure means that like um if there's a failure in the system, send me email. But I put false because I don't want it. I can easily even remove it, but I just want my project to look more commendable actually. So retry is after the if there's any failure, you try again and see if it's going to happen. So the retry is once. Then retry delay is like okay, once there is a failure, wait for 5 minutes. Don't push the system to the limit before it will break. Wait for 5 minutes before you can um, um, go to the next one. So all this consists of that like the default tag. So now next I will use the width. I use the width block. If you read through Airflow documentation, I also recommend you go to read reading through all these things I explain deeper. So I will not have the time to explain what each of these things means. So if you read through the Airflow documentation, you see all these things explained deeper. So next I will go with the width block. So the width block essentially shows it comes with the actual dark setup obviously. So it shows the like it's like a context manager. Let me explain it for you. When I make context manager, I give it a dark ID. I set um the like how the DAG is going to work. For example, this is the DAG ID now. I set how the DAG is going to work, and I also connected the default DAGs. It's my the initial one I explained with you because it's needed in this width manager. So instead of me typing all this inside here, I still use like a variable to reference it obviously. So yeah, so this is what the read tag does. I give it the tag ID, which is my I use this GCP dot by. So if you run this container again, you will see a new tax, and the name of the ID will be this. The schedule is hourly. You have hourly, you have minutes, you have you have days, you have months, you have year. It just depends on you what you want to how you want to run it. So I set my own to run everyone 1 hour. Everyone 1 hour. So I also use this catch up as force as well. And yeah, so now let's move on to the first task. So inside that block, inside the width block, because everything has to be on inside the width block. You can see they are all inside the width block. Inside the width block, I define two tasks. The first task is to upload the local desktop file to GCS, the buckets. So now I'm using this operator I defined earlier up here. This local file system operator helps me to like load and extract the data from my local file, then put it into the bucket. So before I can use it, I need to like define the tax ID, the source, the destination, the file name, and the bucket GCS name. So once I define this tax, the second tax is to load the CSV file from GCS to BigQuery. So now, obviously, the data will be in my GCS bucket. I want to load it to BigQuery. I define the operator, define the tax ID, define the bucket, define the source, define the destination as well. Define the format. The format is I use CSV. You can use packet and others. Um, I also skip leading row. So like the first row contains the columns. I don't want it to be touched. Right truncate. So if the table is there already, um, impute these new columns inside there. So yeah, so everything contains these two tags. This dark file, everything contains this essentially contains this tag, these two dark tags, which are essential in this project. Very, 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 very important. So after that, I lastly state the dependencies. Now the dependency will just tell you, okay, how do you want to run this project? Which one is first, which one is second? So I define the project by running upload to GCS as first. Then after upload to GCS, you upload to BigQuery, that kind of stuff. So this is the dependency. So this load GCS to BigQuery depends on this one. Yeah. So essentially that's how everything is. After I've defined all the tasks that I needed, I will start the whole Airflow process to start working. I'll do Airflow, I'll do Astro Dev start or Astro Dev start, whichever one. But before I do this, there is a very important thing that needs to be done. So because Airflow could get to GCP and GCP will block it from entering. So there's this very, very important thing I need to do. It involves two processes. So it involves the authentication process and also involves the authorization process. So I'll make it more simple. It involves the who process and the what process. The who, which means that when Airflow gets to GCP, GCP is going to ask, who are you? What are you doing here? You get. So that who is, who are you? I need to tell Airflow, okay, this is, it's me that authorize this person to go inside GCP. And like the Airflow will now ask, what is this? What is GCP will now ask, what is Airflow doing here? And these are just the two major things: extracting the data from my local file system to to bucket, then extracting the data from from the GCS bucket to BigQuery for analytics. So majorly, these are the two things. So the first I will explain is the G. Should I? Okay, I'll explain the G Cloud authentication process. So now there are several ways you can do this authentication. I think there are up to three ways you can do this. I stick to doing it once. I stick to doing one of the easiest way. So in your in every system you have like a file called ADC credentials. Now these ADC credentials are like our authenticator credentials are like if any external system wants to like do anything, they need that authentication code which involves the ADC credentials. Now to get these ADC credentials, I can easily do a G Cloud in my in my terminal. I can do G Cloud auth um authentication. It will once I do run this code, to essentially bring out the credentials that I needed. So it's very, very important. Like that credential is very, very important. So I can't I can't show up the credentials here, but I can show you where I store the credential. I stored it under this where the file is. This is my CSV file. I store the credential, which is it comes in a JSON format. If you can see, you say application default credential. This credential is very essential. I can't show you. I wish I could have shown you, but in security wise, you don't ever show what this credential entails. So now, doing this authentication process now, I need to create this credential. Once I've gotten my credential, you can also get this credential in your local file system because I've used it before and I saved it in my local site. I can go there and just copy it. It's the same thing, and create a file here, which is a JSON file. Name it application default credentials and put the credential inside this file here. Goes to my CSV. You can put it anywhere though, but the major thing now you have to do now is referencing it for you to reference it. So now I kept it inside my data folder, and I want to put it inside my environmental and I say environmental sorry environment variable. The environment variable consists of like the user's key details, like username, everything about your computer, about your system is inside your environment variable. If you can reference it, if I can put it inside this my environment variable file, it will be so easier. So once I run Airflow will take the credential. Oh, you say okay, this is where the credential is. We go down, it goes to my environmental variable. This variable consists of so many things. We will be seeing just one here. So you go to my environment variable, sees this Google Cloud application credential, look through where the file is, the path, goes to the path, takes the key. Now it now goes to when Airflow is going, now gets to GCP. GCP will now ask, who are you? It gives this credential, which is inside here, to GCP. GCP now takes it and okay, I know who you are. Open the door for GCP to do whatever it wants to do. Now this is the authentication part. Let me now explain the authorization part, which is very, very important as well. So since you have given Airflow the key, Airflow needs that authorization to do whatever it wants to do. Just like I told you here, these are the authorization here. I'm sorry. These are the authorization here, the tasks it needs to do. Airflow needs to know what am I doing on GCP. You get, so because GCP is just like an open space. Open space. Airflow knows that okay, I have this code, but where is the stuff? In which project ID am I doing this stuff with? Which project am I running this buckets and all this stuff? Yeah. So for Airflow to be able to have this authorization, I need to define it in my Airflow user interface. To do this, you will go to the Airflow UI. Let me open the Airflow UI for you. The Airflow UI. You go to the Airflow UI. You click on user. When you click on user, oh, I don't think it's user. Sorry, you click on admin rather. When you click on admin, you click on connections. This connection is very important. So when you see, I've already created the connection. So you click on add new connection. Once you click on add new connection, what is, let me see if I can edit this. Okay, yeah. So you click on add new. Once you click on add new connection, this will be empty. This field will be empty. You make sure that you add Google Cloud defaults as the ID name. Then you come here as the connection type Google Cloud. You get this. I essentially is working on Google Cloud, that kind of stuff. So once he gets here, you go to you leave this extra field empty, leave it empty, because once you click save, it will automatically get what your automatically gets it you automatically put this thing inside after you are done with this extra field JSON, which is the important one. So the important thing now is that, like, I will show you this. I don't know if I should show you this, but like I don't think, yeah. So just of security wise, although it's not complete, this Google extra Google platform impersonation chain, what it is the IAM, the access manager. So this was created on the Google platform, and they and inside the Google platform, it's what was put under this email, this impersonation cloud chain, was that like Airflow can do two things: can create buckets and also can create tables and data set. Three things rather. So this is the one, like the access manager. The things like, okay, you can't tell Airflow, you can't give Airflow all the assets in your Google Cloud. So in terms of security wise, I gave Airflow this access to just do this thing. Then also for the Airflow also needs to know the project you are doing this stuff. That's why I stated the project ID. Do this on this project ID. So yeah, essentially these are um, the two most important things that Airflow needs to know about: the authentication and the authorization. Authentication is that, like, okay, Airflow needs to pass through GCP before it can work. So if Airflow doesn't pass through GCP, nothing can happen. So once you give that authentication, now the authorization, Airflow is authorized to do all these things, create carry the buckets from carry the data from my file storage to the bucket. Yes, authorized to do this. Carry the file from the bucket to BigQuery for analysis. So yeah, so basically this is how my project looks like. Once you do Astro Dev starts or Astro Dev starts, everything will beautifully happen. So let me go to the UI once again. Oh, this thing is okay. Let me go to the UI. Once the Let me go to the DAGs and show you how it runs. So this is how it's running. Although I've seen some tool fade. I ran this DAG hourly. Okay, let me go DAG run. Sorry, mistake. Let me go to DAG run. So it's opening. So yeah, if you can see, I kept it in on hour. So every 1 hour, this DAG will run. You get, every 1 hour it will run. You can see 11, 12, 1, 2, 3, 4, 5, and 6 it failed. I need to check what happened. 7 it failed. I need to also check what happened here. So you continue running, fail, run. So every 1 hour is running, and what is done is that like it's going to my file storage, taking the data from my file storage, putting it on the bucket. From bucket, it's not taking it to the final destination, BigQuery. So essentially, this is how my project looks like. Thank you very much. Thank you, Ifeanyi. Thank you, dear community, for everything you have done. So I think this means a lot. I will go deeper into learning what Airflow is, and yeah. So thank you once again. Yeah. So if you want to also check more about my project, I have the GitHub link. I'll send you the GitHub link. I'll put it under because I'll be posting this video on YouTube as well. I'll put the GitHub link there to check more about the project. Yeah. So thanks for watching.